Hello friends, welcome to Macnotech YouTube channel. Friends, we had already completed 75 questions for machine design objective, and today we are going to see 76 to 100 questions for machine design. Let us start. The shear stress in a beam vary from 0 at outer fibers to the maximum at neutral surface. The answer is yes. Why? Because on the top of the fiber there is no another layer on the top. So there we can say there is no shear stress on the top of the fiber. But at a neutral axis we have a maximum layer above and below it. So we have a maximum, we can say, at the neutral axis in the most of the cases. So here answer is A. 77. The stress which vary from minimum value to the maximum value of the same nature, like tensile or compressive, is called the fluctuating stress. Answer is C. Okay, above and below. Then 78. The endurance or fatigue limit is defined as the maximum value of stress which a polished standard specimen can withstand without failure for infinite number of cycles when subjected to. Answer is completely reverse load. Okay, so here 78 answer is D, completely reverse load. Then failure of material is called the fatigue when it fails below the yield point. Okay, if it is failed below the yield point, then it is called the fatigue failure. Okay, then 80. Here you can see this is a completely reverse stress. Like from the center, the maximum and minimum will be the same. Okay, and here you can say this is a fluctuating stress. Okay, so this is the difference between these two, completely reverse stress, and this is a fluctuating stress, and this is a repeated stress. You can see here the reference line is over here, and minimum stress is 0, and here this is a maximum stress. Okay, and next is the resistance to fatigue of material is measured by. Okay, so it is measured by the endurance limit. Okay, answer is D. The yield point in a static loading is blank as compared to fatigue loading. So answer is A. 81 answer is A. Then factor of safety for fatigue loading is the ratio of. Answer is C, endurance limit to the working stress. Okay. Then 83, when the material is subjected to fatigue loading, the ratio of endurance limit to the ultimate tensile strength is. Answer is 0.50. Okay. So if we talk about fatigue loading, then the ratio of endurance limit to the ultimate tensile strength is 0.50. Now 84. The ratio of endurance limit in shear, here it is a material is subjected to fatigue loading. Okay, and next the ratio of endurance limit, here we are talking about endurance limit in shear to the endurance limit in flexure. The ratio of these two is 0.55. Then 85. The endurance limit for the mirror polished material will be higher, or we can say more, as compared to unpolished material. Okay, so unpolished material having an endurance limit is less compared to mirror polish. Okay, if the size of the standard specimen for fatigue testing machine is increased, okay, if the specimen size is increased, then endurance limit of material will decrease. Okay, so it's obvious that if the size is increased, then mass is increased, so momentum is also increased. So during rotation, it's a chance of failure is more, so the strength is decreased, endurance strength is decreased. Okay, now the surface finish factor for a mirror polished material is 1. Answer is 1. The fatigue limit of a material is greatly decreased by poor surface condition. So it's absolutely right, because whenever poor surface condition of any material, it have a less strength, so fatigue limit is also less. Okay, poor. So answer is A. Okay, then 89, the stress concentration is caused due to. So you know about the stress concentration, right? So it is caused due to the variation in load acting on the member. It's right. variation in property of material in a member, right, and abrupt change of cross section, it is also right. So answer is all of these are the reason, okay, because of that stress concentration is generated. Now the stress concentration factor is defined as the ratio of, so here in this figure you can see this is a maximum and this is a minimum stress, right? So it is the ratio of maximum stress to the nominal stress, not a minimum, but it's called the nominal stress, right? So here it's a maximum to nominal stress. Okay. Next is the value of stress concentration factor depend on. So the value is depend on the material as well as geometry of the part. Answer is C. Then 92, in a static loading, stress concentration is more serious. If there is a static loading, then it is more serious in brittle material. Okay. And if it is a cyclic loading, okay, 93 question is that cyclic loading, stress concentration is more serious in ductile material. Okay. So for the static it is brittle and for cyclic it is ductile material. Now 94, a plate with an elliptical hole in the center. Okay, there is a plate and there is a elliptical hole at the center in which semi-major axis perpendicular to the direction of loading. Semi-major axis is perpendicular to the direction of loading and semi-minor axis along the direction of loading. Okay, and it is subjected by pull P, means there is a load. Okay, then the maximum stress induced at the edge of the hole is equal to, answer is B, sigma bracket 1 plus 2A upon B. So here A is the semi-major axis and B is the semi-minor axis. Now in the question 95, same question if you consider, and if the semi-major axis is twice than the semi-minor axis, then the stress induced at the edge of hole will be, answer is 5 times. Okay, semi-major axis is twice the semi-minor axis, then it is 5 times. Okay, now same question, but semi-major axis is half than the semi-minor axis, then the maximum stress induced at the edge of the hole, that is double. Okay, so 96 answer is A, double. Okay, then 97, a plate with the circular hole. Now instead of elliptical we consider as a circular hole in the center is subjected to pull P and the maximum stress induced at the edge of hole 3 times of the nominal stress. So answer is correct, right? Now question 98, the fatigue stress concentration factor is defined as, the answer is B, it is the ratio of endurance limit without stress concentration to the endurance limit with stress concentration. So answer is B. Now 99, the notch sensitivity Q is expressed in terms of fatigue stress concentration factor Kf and theoretical stress concentration factor Kt as. So here notch sensitivity Q is equal to, we can say Kf minus 1 upon Kt minus 1. Okay, so answer is B. Now last 100, the design calculations for the members subjected to the fluctuating loads with the same factor of safety yield the most conservative estimates when using, answer is Goodman relation, because here it is considered as a yield. So here answer is C, Goodman relation. So this is enough for today, and next time we will see another 25 questions. So friends, if you like this video, then press the like button, share this video to your friends and subscribe my YouTube channel. Thank you. Jai Hind, Jai Bharat.